Good day, good day, and welcome to Africa Teen Gigs Online School. This is your physical science grade 11 class. If you've just joined in, my name is Nonkulilego Madondo, and I'm so happy to see all of you guys back here again and here for some more physical sciences. As you know, recently we've been busy with chemistry and we're still continuing. Our topic for today is going to be reaction solutions. We're moving on from our topic on Friday, which was experimental solutions, and we're just carrying on. I just want to remind you guys that in our in our physical science class, we are using most of the time. I like using the Oxford Successful textbook. I think you guys have seen it more or less, and some students are actually using it, and that's the one that I usually use. You guys can get it from Snaplify. You can just register on Snaplify and get login details. These textbooks are absolutely free. So you guys can go out there and get yourself some textbooks and all for all your subjects actually. Just sign up with Snaplify. They're actually doing this program. It's going to be free to download all these textbooks for the whole year. And I'll also today I'll also be using um, the maths book no, excuse me for saying maths. I'll also be using the other physics study master. Yes, I'll also be using study master. So if you also have it, these are the books that I'm going to be using with you guys today in most of my presentation and some of the pictures that I'm going to be having today. Well, thank you guys for joining in. I can see you guys are right on time. And I just want to remind you guys, if you remember, on Friday, you guys had homework. And I think before we go any further, we need to go to the homework and sort that out before we start our new topic for today. Okay, let me just get this slide quickly. This was our homework for last week, Friday. On Friday, you guys had some questions for activity 2, questions on percentage yield. If you remember properly, we did some problem 1 together, and then I asked you guys to do number 2 and number 3 on your own as homework, and we'll come and discuss it today. If you've had any problems, just send me a chat and I will explain everything thoroughly. But for now, I'm going to go to the answers quickly. You see on number 1, it says, on number 2, it says the reaction of iron phosphate with sodium sulfate produces iron sulfate and sodium phosphate according to the unbalanced reaction. If you look at this one properly, it's unbalanced. And you know whether they tell you or not. The minute you see the word unbalanced, you know that before you start any calculation, you have to balance your equation. So let me just go to the solutions quickly. Um, okay, this is our homework. I always find it's always easier to understand when something is written with a pen compared to being typed. I know we are all fourth industrial revolution, but it relates better when you see actually how somebody wrote it out. So this is our homework number 2. So this is how we balanced it out. I added a 2 here. I hope you did the same. And I added a 3 here. And I added a 2 there. And therefore our equation is balanced. You guys must remember, if the equation is not balanced, you're going to have a problem with all your calculation, because once you get to the ratios and your ratios are wrong, everything else is going to be wrong. So always make sure you balance your equation right and take your time balancing your equation. Not too much, but take your time just to make sure that and count everything. Okay, there's 2FE, there's 2FE there. There's 2P and there's 1P over there. Okay. There's 2P as well this side. So you must always make sure everything is balanced. Always do a checkup again to make sure. Okay. So what are we given there? We're given 15 grams of Na2SO4. And what do we know? Remember our steps. It says when we did it, it says the first step is to balance the equation. The second step, to take what's given whether it's particle, etc., or weight or mass, and you turn it into the number of moles. So we always have to convert to the standard number of moles. Thereafter, for us to find the number of moles, we always have to calculate the molar mass. If you can see here, this is a molar mass of this Na2SO4. You always calculate, they'll never tell you to calculate that one. You just always have to know that the capital M is something that you guys have to find. So that's the second step, calculating the number of moles. After that, we have our moles. We substitute the molar mass on the equation, and this is our number of moles. Thereafter, let me just make the screen a bit smaller so that you can be able to see from the top. Okay. Then after that, for us to find the number of moles for what is required, this is what they're looking for. They want to know how much, what is the mass of this one. So in order for us to find this one, we need to put it in the ratio, and you always put your ratio against what is given. It doesn't matter if there's three arrows on the equation. What is given, it is what you're going to use to find the ratio of what is unknown. Okay, so here we have it, n1, which is this one of the given, divided by 3. As you can see here, it's 3. The ratios is always what is in front of your compound. If there's nothing, it means that it's a 1. So you'd naturally write a 1. So this is the answer for it. Okay, then you're going to cross multiply both sides, and this is the answer that you're going to get from that. And don't forget, guys, always write 0.07 mole of Na3PO4, so that just to be clear on what you're actually looking for. Because sometimes if you don't write of ABC, you tend to forget. Maybe when you go to the next step, you're trying to remember, oh my word, what number of moles was I actually looking for. So make sure that you always write it down there. Okay, now that we have the number of moles for this, it means that we can now calculate the mass of it. And to calculate the mass, we need once again the molar mass. So how do you calculate the molar mass? You calculate it this like this. Don't forget, anything that has a subnumeral underneath needs to be multiplied. So if it's Na3, you're going to say 22.9 times 3, put it in a bracket, but the elements on individual context, they have to be added together. So it's going to be plus PO plus 4 times the oxygen element. Okay, so this is the number of gram per mole that we get. So here, what they want to know, they've given they've given us the percentage, right? They say if it's got 65%, and um, what is the actual yield? Once they give you the percentage, you can find the actual yield. Why? Because the theoretical yield is what we calculate. So we just need the information of what's given for us to calculate the mass for the theoretical yield. And therefore, I divided both sides by 100, which will give us the 0.65 times 11.47, and that actual yield will be 7.46 gram. Are we all together? I hope I'm not leaving anyone behind. If you are getting left behind, of course, you can just send a chat and tell me, ma'am, I can't see A, B, or C, and then I'll go back and I'll explain that quickly. But that marks the end of this problem. And so yeah, basically it's what we've been doing. It's just that now we've added percentage to it, and you guys must always remember that with chemistry, it's all builds up. Everything is a chain. You will need the previous calculation to add on the next calculations for the next topic. Okay, so let's move on. Let's go to number number 3. Okay, number 3 says propane is burnt in excess oxygen. The reaction that takes place is C3H8 plus 5O2 will give you 3 CO2 plus 4 H2O. Okay. So for the first one, they ask calculate the theoretical yield of carbon dioxide if you start with 5 gram of C3H8. And then number 2, they ask the percentage yield is 75%. Calculate how many grams of carbon dioxide are produced. And then the third one says carbon dioxide has a negative impact on our food security. Discuss the impact. Okay, so let me go to our solutions quickly. But you can already see what's happening here already. You know that you have to find the number of moles. That's your first step. The minute you see gram, you know it has to be converted into the number of moles. Okay, so let's go to our solution. Okay, we're done with this one. Okay, number 3. Okay, our equation, we balance it first, which means we add a 3 there and a 4 there. And then our equation is balanced. So for 3.1, number 1, we look first step once again, we look for the number of moles. We convert whatever is given to number of moles, and this will be what we get, and this is our number of moles. And then we go back to the ratio. Because they're looking for carbon dioxide, we're going to take this ratio here, the 3 there. Yes, and then which means we're looking for the number of moles of carbon dioxide. Okay, and this will be our answer. It will be 0.34 mole of carbon dioxide. Okay, write it so that you can remember what you were looking for, because you know a reaction is long. Maybe when you're in the exam, you'll be writing and then you'll forget, oh my word, kind of what is the number of moles am I looking for here? So it's always better to write it so that you can remember, okay, this is the mole of carbon dioxide, which means the next step I have to find the mass of carbon dioxide. Okay, for this case, which means you're going to look for the molar mass again, because now you're not looking for what was given, you're looking for what is unknown, and you look for the number of moles there, and then you find the mass. Okay, sorry guys, I forgot to write my gram here. There should be a gram. Don't forget your standards, because your standard units, because if you don't have your standard units, your answer is wrong. Just like me there, I'm already wrong, so do make a correction there. Okay, and then this is the mass that they wanted, so it's 14.96 gram. Okay, gram of carbon dioxide. Okay, and then you move to 3.2. They ask the percentage yield. They're looking for the theoretical yield. Okay, no, they're looking for the actual yield. Okay, so it's going to be, no, they're looking for the actual yield. So it's going to be percentage yield times theoretical yield. Okay, so that will be 14.96 times 0.75, because they said it's 75%. And this will be your answer. There should be a gram again once there. Don't forget, guys, to put in your standard unit. And if you are stuck somewhere in this problem, just send me a chat and I'll check it for you. But I hope that we are all in phase. Okay. And then now they ask, what is the effect of carbon dioxide on our food security? Well, that one is a discussion. There's no wrong or right answer as long as you have facts that you can prove. Okay. It says a higher atmospheric concentration of carbon dioxide increases the growth of cereal crops. Okay. This decreases nutritional value of rice, wheat by lowering the amount of protein, micronutrients, and B3 vitamins. Okay, so that's a problem with carbon dioxide, because when it's too much, um, it affects the food that we eat. So basically, if there's too much carbon dioxide, our food is affected because we don't get all the nutrients that we need. Okay, they are there, but not enough. It decreases them. So that's the problem with carbon dioxide. I hope that you guys are happy and you got 100% for your homework. And please, guys, keep doing your homework because practice makes perfect. Here, we learn by doing. So, in order for you to understand what is happening, you just have to learn and practice and practice and practice. Okay. So, now we're going to go to today. Okay. So, we're moving on. Today, we are doing Unit 6. I'm reminding you that we're working from the Oxford Successful textbook. So, we're following the units according to that book because many books have different sections and different units. So, if we don't follow through a certain one, we're going to get confused and I'm going to confuse you guys. So, it's better to work on one textbook, get all the different information that you need, but follow a certain unit so that you guys can also follow through. So I hope you guys have your textbooks ready there and you've registered yourself with Snaplify to get all the free textbooks for all your subjects. Okay. Outline of work that the outline of the work is that we are still doing chemistry and we're still going to be doing chemistry for some time because we're doing one unit a day to make sure that everybody gets to understand what is going on. So reaction solutions. What are we talking about? Our content, we're going to be talking about concentration of a standard solution. Number two, we're going to talk about preparing a standard solution. And number three, it's going to be concentration of volume in stoichiometric calculation. Okay, concentration of a standard solution. This equation, when you think of concentration, you must just think of C is equals to N over V. And concentration is expressed in 1 mole per dm3. That's another thing you must always remember. That's a summary of concentration of a standard solution. Okay. Concentration is very precise. Solid is dried out and weighed to get an exact solution. So basically, when we talk about a standard solution, we talk about a solution where the the amount of substance that is calculated is exact. Basically, it's exact solutions that are weighed in order to get a certain amount of solution. Okay, they are used for exact amount of concentration which is added into a volumetric flask. Okay, this one we can include sodium carbonate, sodium oxalate, potassium dichromate. Okay, let's just go quickly to the textbook and see what it says. Okay, concentration of a standard solution. The concentration of a standard solution is the amount of solid that dissolves in each liters of a solution. The concentration of a standard solution is usually given in mole per dm cube. Okay, let me just show you guys how does it look like in an experiment when you're adding a solution. Okay. Yes, this is how it looks like. So you can see down here, this is the solid that they're talking about. So this is a substance that is measured. It's specific. So you don't just add anyone. And the solid should be a material that is pure and doesn't easily react with any chemicals and can dissolve. Okay. So here, as you can see what's happening here, they've put the solid in the volumetric flask and then they're adding the liquid. It could be pure water or yeah, it's water. So basically they're putting water there and then they closed the volumetric flask and they shake it together and this is our standard solution. So here you can see they put a CuSO4. Now it's a liquid. First it was a solid. They added water into it. They closed the flask, shaked it, and this is our solution. And that solution is what we call a standard solution because it doesn't need to be heated. It can just get you your result without having to burn gas cylinders, etc. Okay, let me just go back. Okay, So there we are. So preparing a standard solution. What does this mean? When you prepare a standard solution, when a standard solution is prepared, a primary standard is dissolved into distilled or purified water. So what is a primary standard? A primary standard is, for example, when we look here, it's this solute, the CuSO4. It's a solute, but it's also a primary standard. Yes, it's a primary standard. So a primary standard is reagent that is able to dissolve with liquid without reacting with other chemicals and has a mass, something that you can measure. Okay, solution is placed in a volumetric flask with the primary standard. Okay, so preparing a solution, we use 3 steps in preparing a standard solution. Number 1, in a volumetric flask, you take a volumetric flask, you convert the units to dm cubed. Okay, why are we doing that? Because when our concentration has a unit of mole per dm cubed. So that's why we also have to make sure our volumetric flask is converted to dm cubed. Okay, number 2, we work out the number of moles using the given concentration and the volume. So what does this mean? This means that when when you are given an experiment, for example, to do a standard solution, they will give you the number of moles, they will give you the concentration and the volume of, they'll give you the concentration and the volume of what is needed, but they won't give you how much the mass is. So what you need to do, you need to calculate the mass. And how are you going to do that? Calculating the mass, first, you need to work out the number of moles. Remember what we always say, take whatever is given, turn it into moles, and then after that, you can calculate the mass, or you can use the ratios as prescribed. But today, we're going to be learning a new different calculation that's added into every other calculation that we have. Okay, so this is what I was talking about. This is our solute or primary standard that we can mention, and this is either distilled or pure water that you mix through the funnel, and then you close it, you shake it, and you get your standard solution in liquid form. So I hope that you guys are understanding closely what a standard solution is. A standard solution is a liquid solution where 2 substances are added together to form one liquid form, aqueous form. Okay. Okay. So now we move to concentration of volume in stoichiometric calculation. Okay. Number 1. Okay. Here I've got another book that I'd like to share, but I'm not sure if I have it in line. Okay, it's not here, but let me see on Snappify. Okay, we are still here. We've actually moved on quite far because we've spoken about the concentration, the standard solution, but you know, okay, preparing a solution. Okay, yeah, that's an example that I need to do. Preparing an example, preparing a solution. This is an example. Okay, like I mentioned, there's 3 steps that will give you either the concentration or the volume. Okay, or they give you both. They give you the concentration and the volume. So what do you do? As you can see here, determine the number of moles. Everything that you get, you always first have to convert it to the number of moles, and then you determine the mass. So which means 1 gram of NaOH must be added to 250 cm cubed flask to obtain a concentration of 0.1 mole per dm minus 3. Do you guys understand what this means? It means that this preparing a standard solution, you have to do the calculation before you do the actual calculation. And when you start your experiment, you need to know what you need. They will tell you that we're going to give you a solution of zero point 0.1 NaOH, and we're going to give you a volume of 250 centimeter cubed. Okay. So what they haven't told you, they haven't told you how much of NaOH must be added into this solution to give us the expected result, which is stated here. Because this is already the solution. This is basically the answer. So here we're working back from the answer to where it started. So they want 0.1 mole per dm cube. So they want to know how much of NaOH are we going to need to achieve this result. So that's why we're working back. And don't forget, guys, whenever you see cm cubed, know that you have to divide it by 1,000. We always work with the standard unit of dm cubed. So first thing you do, you convert to dm cubed, and then you find your number of moles, and then you find your mass. And please do, if you can, still have time, right? NOH must be added to 250 centimeter cube flask to obtain a concentration of 0.1. So this, in a way, it's a pre-prep. Basically, that's what you do usually in the lab. Whenever you go do experiment, there's always going to be a pre-prep that you do before you do the actual experiment, and you compare it with the two. And sometimes looking for the mass like this one, it's something that you have to manually calculate. Okay. So I hope that that is making more sense. So this is another experiment. I wanted you guys to see it, how it practically looks in real time instead of a drawing. Okay. This is the solute. This is a primary standard. This is what you're going to have, and we don't know how much this is. So you see what we're doing now. First, we started calculating. They already told you they want a solution of 0.1 mole per dm minus 3. So what have they done? First, you calculate how much of this you need. So that has been calculated now on the previous problem. We know it's 0.1 gram of NaOH. And then now you take it, you put it in your volumetric flask, and then you add the 250 centimeter cube of water, and then you close it and you shake it, and this is your final product. Do you guys see it now? I think it makes more sense when you see it live, but this is what we calculated. I hope that it makes more sense. If there's somewhere where you stuck, just drop me a chat, and I will go back and explain it some more. Okay. So this is our method. Okay. And don't forget, when you guys do experiment, don't forget to discuss and write what you've seen with your eyes. The time is coming. You guys are still going to do a lot of experiments, especially when the school reopens. So you must make sure that you always write what you see, and you discuss it, and you conclude that your solution was done, how, and every steps that you guys have taken. Okay. And then now we move to the concentration and volume in stoichiometric calculations. Okay. Um, let's go back to our slide. Okay. Now the concentration of volume in stoichiometric calculation. What are the steps that we need to take? First of all, we need to balance the equation. Okay. And number two, this is how the equation will be. We're going to have the A of the acid, which is the ratio, basically, what we usually call the ratio of the acid, plus the ratio of the base will give you the product. Okay. So how do we now get the product? The product is what we're going to be looking for. So in this calculation, basically, we use A plus B, we merge them to find our product. And this is how it is. They'll give you the number of moles of the acid divided by the number of moles of the base is equals to the ratio of the acid divided by the ratio of the base. I don't know, are you guys following? But I think we're going to do an example, and you guys will be able to see it when we do that. So here, they'll give you this side. Remember before, they usually gave us, for example, a base and asked us, how did they get the product? But in this case, we're looking for the product. So it's going to be the A and the B will give you the product. And this is the equation of the product. And you can check it out. It's very much in detail there on the study master for grade 11. You can check it there. That's where I got this information from. So you can check it there. It's more thoroughly explained. But basically, that is what's happening. If you guys are feeling a bit lost, you can just let me know and I'll go back to it and check it. Okay. Okay. So now I just want us to go and check our problems that we did, that we're going to be doing. Okay. So there is an example. Yes. So with this one, the steps is you consider this. We always, in this case, I want us to use method B because we've been using method A for all the other problems. So with this one, let's try and use method B. I think it's much easier. It's what I showed you guys. So it's going to be A divided by B is equals to CVA divided by CVB. Okay, this is both on the reaction side because this part is what is going to be given, and what you're looking for is that part. So um, these are the steps that you're going to have to take. Number one, obviously, we start with a balanced chemical reaction. We balance the equation. And why do we do that? Because we're going to need A and B. These ones is the ratios that we're going to get from our balanced equation. Okay. And then we substitute it in the equation above. And then for the volume, if they've given it to you in cm cubed, you need to convert it into dm cubed. And one of the concentrations will be given to you, and you'll be looking for the other one. Okay, I hope you guys understand it. Yeah, let's look at this method B. Just the same thing, but this one we've worked with this procedure. I just want us to get more into method B. Okay, it says write a balanced equation, which is what we did, and then substitute the equation. So what have they given us? They've given us 25 centimeter cube of hydrochloric acid of concentration 0.12 mole per dm minus 3 reacts with 28.4 centimeter cubed of sodium hydroxide solution to form water and sodium chloride. Calculate the concentration of sodium hydroxide. So what are we looking for? Sodium hydroxide is this one here. We do not know what is the concentration. So you can put everything there. As you can see, everything is a 1 here because there's no numbers in front of the compounds. So it's going to be A over B, it's going to be 1 over 1 is equals to the concentration. You write the one that's given, the one of hydrochloric acid, times the 0.025 per dm cubed, right? And then you're going to say that divided by Cb, which is what we're looking for. We're looking for the concentration of sodium hydroxide times by 28.4, which is what has been given to us. Do you guys see how simple this equation is? It doesn't go the long route where you can possibly make a mistake somewhere and everything else is wrong. So always, if there's something that makes your calculation easier, always take that route. So this one, when you see the ones with two volumes and concentrations and looking for concentration, always know this is the equation that you guys have to use. Okay, so let's continue. I think there's some problems that we're going to be doing, and that I hope that will bring a clearer picture to you guys. Okay, so let's check what's happening on activity 2. Okay, number 1 says A standard solution is made by dissolving 5 gram of NaCl in 500 cm cube of water. Okay. Calculate the molar concentration of the solution. Okay, let's go and check it out. Okay, activity 2, here it is. So first thing that we do, NaCl and H2O, we know that, there's those formulas that you just need to start, these equations that you need to start knowing in your mind, that if this acts with this, this is what it gets, because it's going to help you, especially when you get questions like the one we've just received now, that doesn't actually give you the equation, that you have to actually know what equation it is. So it's a NaCl plus H2O will give you sodium hydroxide plus HCl. Okay, so what they say here, they say 5 gram of NaCl is given and 500 cm cubed of H2O. Okay, so what do we do now? We know all the time, the first thing that we have to do, convert what is given into number of moles. And then that's where we see there, we've calculated the molar mass of NaCl. And now we find the number of moles. Always, guys, don't forget, first thing you do, convert what is given to number of moles. And this is what we have. So it's going to be 0.086 mole. And then now we need to find the concentration. Now that we have the number of moles, we can find the concentration. So it's going to be number of moles divided by the volume, which is 500, is going to be 0.5 if you convert it to dm cubed. And your answer will be 0.172 dm mole per dm cubed. Okay, this is not right. It's supposed to be stroke. My apologies for that. It's supposed to be stroke, guys. Make sure you write it well on your side. This is supposed to be a stroke, unless I put a minus there, and then it can be a dot. So I hope you guys are understanding it a bit more. This problem was quite simple, but sometimes it can be tricky, especially when you see 5 gram NaCl, 500 of H2O. But you guys need to know, first take what's given, convert it to number of moles, and then you put it in the standard formula of C is equals to N over V. Okay, let's go now to number 2. Okay, let's see what they say on number 2. They say 25 cm cubed of 0.2 mole per dm minus 3 of NaOH and 30 centimeter cube of a solution of sulfuric acid reacts completely to form water and sodium sulfate. Calculate the concentration of the acid. Okay, the unbalanced reaction is this one as followed. Okay, so what are we looking for here? They're looking for the concentration of the acid. What is the acid? The acid is the result of the two, it's the result of the two, NaOH, H2SO4, okay. Solution of sulfuric acid, okay. So now they're looking for the concentration of the sulfuric acid, this one here. This is what they're looking for, because they gave you the volume and the concentration of NaOH, but here for the H2 sulfuric acid they only gave you the 30 centimeter cube. So what are they looking for? They're looking for the concentration of the acid. Now let's see how that is done. I hope that everybody is following through and is getting to understand more or less what is happening, especially with these ones. We're still moving slowly, but we're getting there. We're going to get to the, but it's not going to be so hard if you have been practicing everything every day and doing your homework and doing your corrections and understanding. And wherever you guys get lost, please don't forget to ask me what is the problem and tell me what's the problem, and I'll see how I can explain to you guys thoroughly. Okay, so now here is our equation. which was given and was unbalanced. So I managed to balance it by putting a 2 there and a 2 there. You guys see that? So which means we've got 2 Na here, there, 2 Na there. We've got 2 O's plus 4, it's 6. And then here it's 4 plus 2, it's 6. And then the H's, we've got 2 plus 1 is 3. It's 2, it's 4 actually. The H's are 4. And then here, this side, the H's are also 4. Then we've got the SO. S is 1 in both sides, and O is 5, is no, this is 4 plus 6, and this side is also 6. So it's balanced, guys. Make sure that even after you balance it out, you write them each individually on both sides and see if you've got the equal amounts of each. Because one mistake, everything else is wrong. This problem is completely wrong. Okay, so here we're going to say A over B is equals to CAVA divided by CBVB. So these C's, these are the concentrations, these are the ratios, and the V's are the volumes that are given. Okay. Sometimes you can find that they'll give you the concentration and ask for a volume of one of the two. So that one can also happen. Okay. So what do we do now? We're going to say 2 divided by 2 over 1 is equals to, because on A, you see, this is a 2. That's why we've got a 2 there. And this, all of this is given. And then for the sulfuric acid, it's only 1. And if you check underneath there, everything is given. Everything is given except for the CB. Okay. And the CB, which is the concentration, is what we're looking for. So how do we find the concentration? We're going to say 0.2 times 0.025 over 2 times 0.03, and that will give us 0.083 mole per dm minus 3. I hope that this makes more sense to you guys if you guys see it practically, but that is how the problem is done. Okay, yes, this is how the problem is done, and I hope that it brings more light and you guys will be able to start doing your homework for tomorrow. Guys, we are moving fast because I want us to get to, you know, by the end of chemistry, I want you guys to be so understanding of it that it doesn't even take too much for you guys to do a simple problem. That's why we're going slowly and taking it step by step, each unit at a time. I know sometimes you feel like other things are repetitive, but it's good because in your mind is getting into that rhythm of understanding how to calculate each chemical reaction. I mean, always looking for the number of moles. I know it can be really stressful, but it's good because now it's building a pattern in your mind for you to be able to do your work. Okay. So now for tomorrow, um, we're going to be moving to a new topic again, which is unit 7. You see, we're slowly finishing chapter 5, but after this we're going to jump straight to chapter 7. But for now, we're going to be doing the unit 7, which is limiting reagents. Okay, that is, so you guys can read it up for today and see, you know, where you guys are getting stuck. Or okay, let me just see. I see there's a chat there. Um, we have 2 minutes left. Yes, indeed. And I hope that you guys understand everything that has been spoken about. Um, so tomorrow for homework, I'd like you guys to try and do number 4. Okay, let's do number 4, guys, and see um, how much of our understanding is there when it comes to reaction solutions. And I hope that you guys are doing your homework, and I believe in you guys. We can do this if we work hard and motivated and we do our work. So let's meet again tomorrow at 12 o'clock exactly. We'll be starting our lesson. From me, Nonkululego Matondo, I am signing out. And please, guys, don't forget to do your homework and don't forget to check me as well on LinkedIn. If you have any problem, you can find me there. Best regards.